Today's podcast, which I'm doing from the beautiful, leafy, and historic city of Kiev, is going to cover, I think, a problem everyone faces, at least 95% of people would face, is the fact that their calculations or their arithmetic tends to be very poor. And I would say that in 95 to 99, I would say probably close to 98% of candidates, they are weak on calculations, which is surprising. I'm talking about PhD candidates. We have PhD candidates from MIT, PhD candidates from Berkeley, PhD candidates from Cambridge who are weak on doing calculations, which is very surprising. And most candidates, when I speak to them, they'll tell me that their biggest problem is not the calculations, their speed. And I find that very surprising, What do you mean? If you're going to become faster, your calculations will become better, which is counterintuitive, right? Obviously, if you try to be faster, your calculations will actually deteriorate in quality. And when I explain that concept to a candidate, they always are surprised because it's obviously logical. If you're doing badly with calculations now, don't you think trying to make it faster is only going to make you worse? And then when I point it out, they say, yes, that makes sense. So obviously speed's not my problem. No, speed is never someone's problem. If speed is your problem, then it's not the solution. What do I mean by that? When candidates worry about speed, they tend to try to be faster. And I always tell a candidate, don't try to be faster. Don't worry about speed. When you want to improve your speed, you got to focus on 5 things, or at least in this case, I'm going to cover the 4 main things, right? I'm going to leave out arithmetic because I'm assuming you can do arithmetic, right? 4 things really damage candidates when it comes to doing calculations. I'm talking about candidates who have PhDs in mathematics, physics, astrophysics, molecular biology, economics, and so on, right? The first thing, right, is I think just candidates have very weak visual layout. What I mean by that is that when a candidate does a case with us, usually an estimation case that is really going to put them through their paces in terms of whether they can do calculations, I always ask them, load up the sheet on which you did your calculation, and I can almost guess what I'm going to see. It's usually horribly structured. The sheet looks messy. Things are not neatly arranged. And in the middle of the case, I always ask a candidate to go back and look at a part of the calculation they did earlier. And when I ask a candidate to go back and look at that part, when a candidate goes quiet for like 5 seconds, I know they've done weak layout. Because of their weak layout, they can't even see the calculation they should have done earlier. They can't even find something they wrote just a few seconds ago. And that's what slows them down. In a calculation case, it's very rarely you're going to be asked to do a calculation, give the answer, and move on. Usually the interviewer is going to go back and say, but what if we change this? Or why did you make this assumption? Change this assumption and rerun the numbers. And unless you can go back and look at your own work, you're pretty much dead, right? Now, for candidates who watched our YouTube video on how to solve estimation cases, you've seen the way we like laying out estimation cases. That's the way we lay out all our estimation cases. It's very structured, whereby you write down the question at the top, you determine if it's supply and demand, then you write your equation below that. Then for each part of your equation, below the equation, you write down your assumptions. Below the assumptions, you do the calculation for the step, and then you do the sanity check. 50% of candidates are doing badly because they don't know how to lay out their calculations. They use multiple sheets of paper, they write untidily, and they cannot refer to things. You write neatly, you write in a clean format that you can follow and that the interviewer can read upside down, you'll be fine. Beyond weak visual layout, many candidates have poor technique. Poor technique means just the way you do math. And one of the techniques we teach is that, in a case whereby we're trying to work out the number of bagels sold in a Starbucks in the United States, we'll say number of cashiers, number of hours they work, and then we have to work out the number of bagels they serve per hour, right? Many candidates will then create a separate calculation to do that. That's poor technique. Good technique is where we'd say something like number of cashiers times number of hours they open times 1 over the amount of time to serve 1 bagel. Right? So we put it cleanly into the equation and everything flows naturally. Poor technique is where you're breaking up everything and you can't put it together again. So there's all these little tricks, right, on how to do these math shortcuts. They're not difficult. They're high school stuff. If you're not familiar with them, I would recommend looking at material for GMAT preparation and arithmetic. So that's the second point. The next 2 things that really baffle me, right? Firstly, missing units. It shocks me how many candidates forget to use units. We'll even tell them the units. They'll go through their calculation and ask them, okay, your answer is 13 million. 13 million what? And then they'll say, well, 13 million. And I say, okay, but what is the units? 13 million people, $13 million, 13 million hamburgers per country. What is the unit? And they'll say, I don't know. And that's why candidates fail. They fail for 2 reasons. Firstly, the answer at the end doesn't have units. But more importantly, because they're not carrying units through the calculations, they misunderstand what the number means in the calculation and they use it correctly, which means the answer they get at the end is wrong. So you have to use units. Units are the language of mathematics, right? And finally, I find candidates make the equations too complicated. Let's assume I had to ask someone to calculate the amount of dollars they spend taking the subway in Toronto in a year, right? I would expect them to say something like number of times traveling for work in a week, right? Plus, in brackets, number of times traveling for leisure. So they'll get a total, that's like 5 plus 2. Then I'd multiply that by the number of trips going to the destination times number of trips coming from the destination, right? Times a percentage for unplanned trips. I'd say 10% more would be unplanned trips. Maybe I had to go for a meeting or something like that. Times 7 times 52 to get to amount spent per a year times the cost of one subway token, right? Now, you notice what I've done there? I've put all the volume on the first part and then I put the price at the end. Now, what a lot of candidates do is they build very complicated equations. If it's the total expenditure is price times volume, price that you spend times the volume of trips, I would expect you to separate the two. But what I find a lot of candidates do is they'll mix it up, right? And this is a simple example, but imagine a complex example where you have a high-level equation, but then when you're building that equation into the little steps, you continuously mix them up. You should never mix them up. When I do cases with people, and any of our coaches do cases with people, we drive home that point. If your high-level equation is the total cost is price times volume, your detailed equation should represent that all of the volume calculations should come either first or last, and your pricing should come either first or last, but you never mix them up. Now, this is a simple example, right? There are more complicated examples, and you can imagine what happens when you mix them all up. So I'd say that if you are struggling with calculations, focus on 4 things. Look at your visual layout, and we have examples of that. Look at technique. Technique is something you have to go back to first principles and understand how to do certain kind of calculations. And if you don't know how to work with fractions, you don't know how to work with proportions, you don't know how to work with ratios, go back and understand it and look for shortcuts. If you miss units, you are just dead. And I would say 95% of people miss units in some form or the other. The other one is make your equations simple. When you're building out your equations to solve anything, keep them simple, separate everything, and make sure they are logical.